All right, guys. Forgive me if my voice is a little scratchy today. All right. Today our focus is I'm going to give you some data, and I'm going to want you to graph it in a scatter plot. All right. We talked about what a scatter plot was yesterday. And so today we're going to really focus on like the nitty-gritty details of making the scatter plot. Most students can graph okay. You guys have been graphing since you were in kindergarten. All right. But what's different as you've gotten older is that we're more and more expecting you to take a blank grid and know how to set the graph up, how to label the x-axis, how to label the y-axis, how to count out each line. Okay? What values would you be putting along, what kind of values would you be putting along the x-axis and so forth? The x-axis is time related. So if your data table contains a row that is about time, like months, seconds, weeks, years, minutes, hours, whatever, anything that's a unit of time, that's the x-axis. If there's no unit of time involved, then usually the first column or row is the x-axis. There's exceptions to that, but 99% of the time that's the case. The y-axis is usually if it's, if there's time involved, it's the thing that's not time. And it's usually the second column or row. All right? Scale, okay, the word scale here is what you're counting by in the in your graph. And if you want to know what you're going to count by on the graph, you have to find the largest number in your x values and the largest number in your y values. That'll help you figure out what you're going to count by. You're going to count by what's going to use the most boxes. In other words, you want to use, if your highest number is 30, you want to make sure that you count, at least, more than 30, but not too much more, okay? If you have to draw extra boxes to make it to 30, you didn't count it right. You don't want to count by weird things like 7s, 32s, and 13s. Guys, I try to give you the hint that you should count by try 1s, 2s, 3s, 4s, or 5s. Okay, those are all acceptable. And then after 5, guys, I want you to think about money. All right, we don't have a $7 bill. Don't count by 7s. Don't count by 32s. Don't count by 13s. Think about money numbers, okay? You must count by the same number every time, okay? You have to start each axis at 0 and then count by the same thing every time, all right? We're going to plot points, but we're not going to connect the dots. We don't connect the dots in a scatter plot. Okay? So if we were graphing this data, all right, in financial situations, financial institutions tend to measure time in quarters. That means like a quarter of a year, 1/4 of a year. So 12 divided by 4 would be 3. All right? So that's a unit of time. That's going to be my x-axis. So all of these values are going to get plotted along my x-axis. All right. Well, all right. The highest number in here is 12. I definitely could count by 1s. And easily make it to 12. All right. My second row is the price per share of our stock. And that goes on our y-axis. And the highest number there is 14. So we can still easily count by 1s there. Then we start graphing. 1, 2, 2, 4, 3, 8, and so on until we have the whole graph done. Voila. Okay. One thing I want to point out, I think I forgot to on the last screen, is when you number your graph here, you also have to put the word from the label in the chart. So I put the word quarter next to these numbers that represent quarter. That's labeling. Price per share next to all these numbers that represent our prices. Okay, that labeling is critical. If you don't do that, you lose points. So make sure you're doing the labeling. All right, association. Well, this data goes up and then back down. So there's a pattern to it, but it's nonlinear. And next year when you guys take algebra, you'll learn a more specific vocabulary word for that. You would come to me and you'd say, Sanders, that's quadratic. But we don't have to worry about that till next year. Outliers. No, none of this data really is outside the pattern, so that's a no. Clusters? Nope. Okay, so that's our first scatter plot. All right, now we're looking at how many questions somebody got right versus how many hours they studied. Now, in this particular chart, I would say that the person set it up backwards because this is hours. Hours is the x-axis. And usually we put that on the top row. But for whatever reason, the author of this chart set it up backwards from what we're used to. Oh, it's not quite as wide as I wanted it to be. There we go. Okay, so this represents hours studied. And this data is all over the place. It doesn't go in a particular order. So we're going to look for the highest number, which happens to be 10. Okay, so we have to count at least as high as 10, which we can comfortably do counting by ones again. All right. Questions they got correct is going to be our y-axis, so it's a little backwards from what we're used to. And again, this data is all out of order. The highest number is 30. Okay. Now, we're not going to be able to count by ones. I will also tell you, if we count by twos, we're only going to make it to 28. And like I said, if you have to draw extra boxes, you didn't do it right. So we're not going to count by twos either, because we almost make it, but not quite. So we can count by threes. And that represents questions right. Okay, and then we would just start graphing this. Remember to graph it kind of backwards though. 10, that's why color coding can help. 10, 29, 2, 14, Now, I'm going to skip a couple for a second because I want to make sure that we talk about some of these that are decimals. So this says 7.5 and 27. So here's 7, here's 8. 7.5 is right in the middle. Okay? 0 and 8. 0 and 8. All right? And when you're all done, looks like that. All right? Association. Now, again, here's what you want to visualize in your mind. Most of the dots that appear in the graph follow that line, which is going generally uphill. So we would consider this association positive. Outliers. Well, I would say, you might be able to look at this one and say that they're outliers. I would say they're awfully close. I mean, yes, they're further apart. They're outside of that blue zone. But I don't know. They're close. 8.5 and 22. Remember, if you have an outlier, if you're saying yes, I want you to say the coordinates 2.5 and 26. Okay. Clusters, nope, we don't have a significant cluster. Okay. Good luck, and I'll see you next time.